Number 3, you guys slow down. One transformation that we could do is, yeah, that's an F. I wrote it kind of sloppy because I was laughing at you guys. But when we're transforming, when we're reflecting, if I have the equation y equals f of x, and I want to reflect that over the x-axis, I just take whatever the y value is and I take the negative of it. Okay? So, for example, if I have a graph like this, and my original function looks like this, okay? The x values stay the same, but they're reflected over the y-axis, whatever, or the x-axis, whatever this value is. Let's assume it's like -2, 4. Then I would come down here and say -2, -4. So whatever the y value is, I just reflect that. Okay? And that would give me a perfect reflection over the x-axis. So whatever f of x is, I'm just going to take the negative of that, and that's how you reflect over the x-axis. Now to reflect over the y-axis is a little different. So if I wanted to, say, reflect over y, I would do it a little different. I would say y is equal to f of the negative x value. So then what I would do is I would take the negative of the x value. So if I had a function that looked like this, and this point here was 2, 4, what do I change or take the negative of? Just the 2, just the x value. So I would have the point -2, 4. Okay? And so if I did that for every point along the green line, what I would have is a reflection across the y-axis. Does that make sense? Okay, so that we need to know that because, for example, number 3, they give us a function. And so in that function, yeah, we're going to reflect over both. So the function they give us is 5x minus 9 all over x squared plus 3. And it says reflect over both axes. So if I wanted to reflect over the x-axis, I take the original function and what do I change?
The y values.
The y values. Now one way that you could change the y values is you could say y is equal to the negative of f of x. So that would be the negative of the original function. So if I plug that in the calculator, that would reflect over the x-axis. Now to reflect over the y-axis, I said that it would have to be f of negative x. So what I would do there is wherever there is an x in the equation, I would put negative x. Okay? And then of course you could expand, and so that would give me like -5x minus 9. In other words, push the negative signs through. By the way, when I take the negative x and square it, it's the same as x squared, right? No, because I'm just taking the negative x. Wherever there was an x, I plug in a negative x. Right? And that's it. Now I can verify this graphically, so the first thing I want to do is I want to graph this in my calculator. Hang in there guys, we're almost done. I know the bell's going to ring in a second. Alright, so my original function, we're almost done, hang in there. My original function was 5x minus 9 divided by x squared plus 3. Okay, now if I graph that, this is what I get. That's my graph. And let's do a zoom standard. And that's what the graph looks like. Now, if I want to reflect over the x-axis,
For active announcements, but first a word about ribbon